All right, guys, welcome back. Today we are getting into geometric sequences and series. So a sequence in which the ratio between successive terms is a constant called a geometric sequence. So in the last day of notes, we were adding and subtracting numbers in a sequence. Today we're going to be multiplying, all right? Whether we're multiplying by whole numbers or negative numbers or decimals, that's what we're going to be looking at today. So to find the ratio, which is R, I'm always going to use A2 over A1. So I'm always going to take the second term and put it over the first term to see how it changes. So for this one, A2 would be 9 and A1 would be -6. So my ratio here is basically -3 over 2. So each one is getting multiplied by -3 over 2. Or -1.5, however you would like it to be written. Then it says to determine the common ratio, which is what we just did using this formula, as well as find the next three terms. So we're going to take that -13.5 and we're going to end up multiplying it by -1.5. And that's one thing you can notice. If your sequence goes from negative to positive to negative to positive, your ratio is going to be negative. All right, so when we multiply that, we get 20.25, and then we get -30.375, and then we get a positive 45.5625. So these are the next three terms in the sequence. Okay, so B is obviously looks a little bit different, but we're going to set it up the exact same way. So we're going to put A2 over A1. So we're going to put -81n plus 243. I can't write. Over 243n minus 729. All right, for this, there's going to have to be something that we are able to cancel out. So what I'm going to do is pull out the -81 on the top and see if it has a common number with 243, which it does. So we end up with n minus, because this is an addition and we pulled out a negative, it's going to be n minus 3 over, here I'm going to pull out the 243. So you're basically trying to get n by itself, and in majority cases, at least in our notes, you can pull it out, and 243 goes into 729 as well. And again, we're left with n minus 3. So here, those n minus 3's cancel out, and we're left with -81 over 243, which simplifies to negative 1/3. All right, we have to find the next three terms. We're going to end up multiplying both the first and second number by -1. Well, multiplying the entire thing by -1/3. So if you want, just to show you, 27n minus 81, you'll multiply this by -1/3. We'd end up with -9n plus 81 over 3, which is 27. All right, and then from there, we would multiply this entire thing by -1/3, in which case we would get, let's see, 3n minus 9. And then we would get -n plus 3, and so on and so forth. All right, so you would have to factor that. And it just goes on from there. All right, next, on to the next one. So write an explicit formula and a recursive formula for finding the nth term of a sequence. So explicit. And here we are just mostly talking about the difference between the two, is an is equal to a1 times r to the n minus 1. All right, and so for this specific sequence, we would have to find r, which is our 2 over -1, so that's -2. All right, and then so we would write it as AN is equal to A1, which is -1, times -2, n minus 1. And because we don't know what n is, we're just going to leave it like that. And that's what the explicit would look like. Okay, and then we have recursive. All right, we have AN is equal to R times AN minus 1. All right, and for the purposes of this one, recursive means that you'll have to utilize the last term, the previous term, in order to find the next one, and that is where the n minus 1 comes in. So for this specific one, we would have AN is equal to R, which is -2, AN minus 1. All right, let's move on to example 3. Find the 9th term of the geometric sequence. First thing we have to do is find R. R is 14 over 4, which is 7 over 2. All right, you can leave it as 7 over 2, or you can write it as 3.5. It's totally up to you. So what I am going to use is the explicit formula. We're looking for a specific value here. So we're looking for 9. Well, it's A1, which is 4, times R, which is 7 over 2, to the n minus 1. And because we're finding the 9th term, 9 minus 1. When you plug this into the calculator, you will get 90075.01563. All right. Find A12 if A3 is 32 and R is -4. Well, that helps us a little bit. They've given us some information. First, we have to find A1. All right, the only way we can find A1 is to use explicit formula because it has A1 already in it. So we're going to end up solving for A1. Now, because we know A3 is 32, that's what we'll use. So we would basically set it up as A3 is equal to A1 times R, -4, 3 minus 1. All right, so then we would go ahead and put 32 instead of A3 is equal to A1 times -4 squared. So this then becomes 32 is equal to A1 times 16. We divide by 16, A1 is equal to 2. All right. Another way that you could have done it to find A1, since I know that A3 is 32 and I know that I'm multiplying by -4, I guess technically since each term increases by multiplying by -4, if I wanted to go backwards, I could have divided this by -4 and gotten -8 and then divide -8 by -4 to find A1, which would have been 2. So, I mean, you could have worked backwards to do that as well. So now we have to find A12. A12 is equal to A1, which is 2, times R, which is -4, 12 minus 1. So then we have 2 times -4 to the 11th power is equal to A12. All right, and then from here, put that into the calculator. You will get negative 8388608. All right, and then here, like I said, we're using the explicit formulas because we are looking for specific values. Find the 9th term, find the 12th. All right, write a sequence that has 3 geometric means between 264 and 1.03125. All right, so how that's going to look is our first value is 264. That means 1, 2, 3, and then 1.03125. So they want to know what these 3 values are in between. We know that A1 is 264, and we know that A5 is 1.03125. All right, so that's where we're starting. We have got to figure out what R is. The only way that we can do that, we're going to have to use, looks like we'll have to be using the explicit formula for that. All right, so let's say we use the explicit. We're saying that A5 is equal to A1 times R n minus 1. Okay, that means 1.03125 is equal to 264 times R to the 5 minus 1, which is 4. Okay, we divide by 264, and we get that 0.0039065. Ooh, because we took a 1 point whatever and divided it by 264, which made it even smaller, is equal to R to the 4th. All right, so then we put it to the power of 1/4. All right, that's like 4th rooting it. And we get that R is equal to 0.25. Oh, blessings. That turned out really nicely. I was kind of nervous. So then, just to find these numbers, we'll take 264 and multiply it by 0.25, or dividing it by a 4th, if you will. We'd get 66 times 0.25. 16.5 times 0.25, 4.125. All right, and that is finishing off the geometric sequence. Okay, I will continue examples 5 through 7 in the next video.